In Lesson 20, we are going to learn how to multiply fractions using an area model.
To use the area model, it is helpful to remember the area formula, which is area equals length times width, or A equals L times W. Remember, when calculating area, the label will always have the word square in it. So for area, instead of just inches, it would be square inches. Instead of centimeters, it would be square centimeters, and so on. As long as I know that my area formula is area equals length times width, the process of finding area for a rectangle or square is the same regardless of if the sides are whole numbers or fractions. It works the same way. In this first rectangle, my length is 6 inches and my width, or how wide it is 4 inches. To find the area of this rectangle, I take the length times the width. So I take 6 times 4 to get 24 square inches. Area works the same way even if the length and the width of my rectangle or square are fractions. We use the same formula, area equals length times width. Looking at this rectangle, I see that my length, or how long the side is 2/3 of an inch long, and the width, how wide it is 1/5 of an inch long. To find the area, I need to multiply length times width. So 2/3, which is the length, times 1/5, which is the width, so length times the width, gets me 2 times 1 up top to get 2, and 3 times 5 on the bottom to get 15. To get an area of 2/15 square inches. Let's take a look at this word problem in Cubs-It. Mark has a square placemat, so that tells me that all sides are equal. That measures 1 foot on each side. He divides it in half vertically. I know vertically goes up and down. And in fourths horizontally, so left to right. He wants to decorate each part with a different pattern. What is the area of each part of the placemat? To get a better idea of what Mark is trying to do, I'm going to start by drawing a picture. I first drew a square to represent Mark's square placemat. I know that this total length is 1 foot. And I know that this total width is also 1 foot. Mark then divides his placemat in half vertically. So that means that I need to split it right down the middle into 2 equal halves for my placemat. This gives me 2 columns. He then divides his square placemat in fourths horizontally. So that means that I need to break this area model into 4 rows. So each row represents 1/4 of a foot, and each column represents 1/2 of a foot. To find the area of one of these parts in his square placemat, I need to multiply the length, which is 1/2, times the width, which is 1/4. So again, my length is 1/2 of a foot, and my width is 1/4 of a foot. To find area and plug it in my formula, I do the length times the width. So I do length 1/2 times my width of 1/4. I can show this multiplication by shading in the area model. Since I have 2 total columns in my area model, I know I need to shade one of those 2 columns. So I'm going to shade in 1/2. And since I have 4 rows, I need one of my 4 rows shaded. So using the opposite diagonal to show my crisscross, I shade in 1 out of my 4 total rows. Remember from last lesson that the box where they overlap is my numerator. So I only have one box where they overlap. So 1 is my numerator. And the total number of squares in my area model is my denominator. So I have 1, 2, 3, 4, 5, 6, 7, 8 total parts in my area model. So that becomes my denominator. And again, my label is square, and in this problem, foot, or 1/8 of a square foot is my area for one part of my square placemat. If I want to check this answer using the traditional method of just multiplying the numerators and the denominators, I can do this very easily. I know that 1 times 1 is 1, and I know 2 times 4 is 8. I get the same answer. When given an area model, it's also important to know how to work backwards to figure out the equation that the area model represents and also the product that you see represented in the given model. To do this, I can start by counting the total number of rows and columns that I have in this area model because those will be my denominators in my fractions in my equation. In this example, I have a total of 1, 2, 3, 4, 5, 6, 7, 8 total columns. So I'm going to have something over 8. To get the numerator, I count the total number of shaded columns that I have. Here I have 1, 2, 3 total shaded columns. So my first fraction for my equation is 3/8. I then want to count for the total number of rows that I have in this area model. I have 1, 2, 3 total rows, so my next denominator is a total of 3 rows. I see that I have 1, 2 rows shaded, so that 2 becomes my numerator to get my second fraction in my equation, which is 2/3. I can get the answer for this area model without even doing the math by counting the number of boxes where the colors or the rows and the columns overlap. Here I see that I have 1, 2, 3, 4, 5, 6 total boxes that are overlapped. The number of overlapped boxes becomes my numerator. And the denominator for the answer or the product will be the total number of boxes that I have in this area model. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 total boxes, which becomes my denominator. Again, the numerator is the number of boxes where they overlap, and the denominator is the total number of boxes that I have in all. So to answer the question, what equation does this area model represent, we found that the equation is 3/8 times 2/3 equals 6/24. Math is very important when we want to change a recipe. Below I have a recipe for snack mix. Our goal is to rewrite the recipe so that it will only make 1/4 as much. And we're going to do this by multiplying the amount of each ingredient by 1/4. This will make a smaller amount of the recipe in case you don't need as much as the original recipe calls for. So if we want to make 1/4 as much of the original recipe, we would take each ingredient and multiply it by 1/4. So for example, for the pretzels, I would take the original amount and multiply by 1/4 to get the new amount of pretzels that I would need. For the nuts, I would take the original amount of the nuts and I would multiply by 1/4 to get 1/4 of the original amount that I need. You would then go on to do this for each of the ingredients.